All right, this is going to be AP Calculus, Self-Check 4.2 Solutions. As a reminder, this had 4 questions, which means give yourself 8 minutes to solve, and then check the solutions. So here we go. Number 1. This is our function, and I see the words mean value theorem. That means I immediately write f prime of c is equal to f of b minus f of a, all divided by b minus a. I also know my function, so I know I need to have an f prime of c, so let's do f prime of x, and that is equal to 3x squared minus 6x, and therefore f prime of c, just removing the x's and putting in c, so I have 3c squared minus 6c is equal to, and I need an f of b, so it's going to have a fraction over here. I know a and b, because this is a and b, so b minus a is 3 minus 0 on the bottom. F of b, so what is that? F of b is the same thing as f of 3, and f of 3 means I'm plugging into this function here, so that's going to be 3 cubed minus 3 times 3 squared. So 3 cubed is 27, minus 3 squared is 9, times 3 is 27, and I get 0. Okay, so I get 0 for b, minus, I need f of a. What's f of a? F of a is f of 0, and that's going to be 0 cubed minus 3 times 0 squared, which is 0. So once again, we have a 0 on the numerator, so we have a 3c squared minus 6c is equal to 0. Denominator was 3, so that's okay. And what do we do here? We're going to factor out a 3c. That means on the inside, I'm left with a c minus 2 is equal to 0, and that means c is equal to 0 from zero product property, and c is equal to 2. But remember that it can't be 0 because that is an endpoint, so the only value is 2. Yeah, so be careful of, wait, never mind, there's no trick questions in here. I thought there was a 0 and 2, but no, none of those are the case. Okay, number 2. The radius of a circle is increasing at a constant rate. So the radius is increasing, therefore that's talking about r prime. And what can we value, or what can we label here? So r, well, that's a weird prime. R prime is equal to, and it's increasing, so it's positive. It's a positive 0.2. Our units are meters per second. All these have the correct units. I'm not going to worry about units anymore. What is the rate? Okay, so we're talking about the rate. So something prime of increase of the area. Okay, so a prime, that's the question. What is that rate of the area? The instant when the circumference, so it's telling us the circumference is 20 pi. 20 pi. All right, so what do we know? We know area of a circle is pi r squared, therefore a prime. The derivative area is 2 pi r prime. We're also given circumference, so we might want to write that one down too. So circumference is equal to 2 pi r, and it doesn't give us c prime, so we might not need to use that. So let's go ahead and take a look at a prime, because if we can just sub in, we're done, right? So a prime, and we need an r and an r prime. Okay, we don't have an r, so we must use this to figure out the r, and that is the case. So let's do that. 20 pi is equal to 2 pi r, and divide both sides by 2 pi, and you get 10 is equal to r. Of course, the shortcut here is to substitute all of 2 pi r for the 2 pi r. So the shortcut here, and I'm going to do that in this second video, is when I have a prime is equal to 2 pi r, this is circumference, which means I'm going to substitute the circumference 20 pi in for these three constants. Well, they're not constants, there's 2 constants and a variable, but these 3 terms. And then I have my r prime, which it's given to right here. It's 0.2, so all this times 0.2. Therefore, a prime is equal to, remember, if it's multiplied by 10, it's going to move the decimal place 1 to the right, so it's going to be 2 times 2, so that's going to be 4, and then don't forget pi. So 4 pi, there it is. C is the answer. All right, number 3. The radius of a sphere is decreasing. So radius, and if it's increasing or decreasing, that is an r prime. So that's r prime that we're talking about, and it's going to be a negative. So r prime is a negative 2 centimeters per second. Okay. At the instant when the radius of the sphere is 3 centimeters. So the radius is 3 centimeters. What is the rate of change? So we're looking for something prime in square centimeters per second, perfect, gave us units, don't worry about it, of the surface area. Okay, so surface area, capital S prime, that's what we're looking for of the sphere. All right, and it gives us this handy equation that the surface area is equal to 4 pi r squared. All right, well, I mean, if they're asking for S prime, that means we're taking the derivative. So S prime, the derivative, is going to be, bring the 2 down for powerhouse, so that's going to be 8 pi r prime. All right, so from there, can we sub in everything? We need an r and an r prime. They gave us an r and r prime. All right, so S prime is equal to, just plug in and go, 8 pi, and then there's our r, 3, and there's our r prime, -2. Therefore, it's going to be -6. 6 times 8 is 48. S prime is equal to a -48 pi. And there it is, C. All right, and finally, number 4. The top of a 20-foot ladder. Okay, I know it's a ladder, it's a triangle problem, so let's go ahead and make a picture. So we're going to have our ladder. This is the hypotenuse is the ladder. The top of a 25-foot ladder. That means that, we'll say that this is C. C is equal to 25. Is sliding down a vertical wall at a constant rate of 3 feet per minute. So this is, we're going to call this A, and it's sliding, so it's going to be a rate 3 feet per minute, so A prime, and its A prime is equal to 3. When the top of the ladder is 7 feet from the ground, okay, so you're talking about the vertical length, so A is equal to 7. What is the rate of change of the distance between the bottom of the ladder and the wall? So it's asking for this B prime. What is that? All right, so some information that we are going to need to find. We need to find basically everything. We need to find A prime A, B prime B, C prime C. C prime is pretty easy to find. C prime, the rate of the ladder changing, how fast is it getting smaller or bigger? Well, it's a constant. It's not getting bigger or smaller, so it's 0. So we really need to just find B, and then we can plug into our equation. Remember, our equation is A prime plus B prime is equal to C prime. And we don't have the B, and we're trying to find B prime. So let's go ahead and find our B. So in our second little triangle that we can make, so we have a 7, we don't know what this is B, and this is 25. So we need to find that missing length, and I'm gonna guess it's gonna be like 24 or something, but let's see. So it's gonna be 7 squared plus B squared is equal to 25 squared. That's gonna be 49 plus B squared is equal to, is that 625, I think? 625. I'm gonna be so upset if I make a mistake and have to come back to this step, but I'm pretty sure that's right. So that means B squared is equal to 400, oh gosh, the mental math. It's basically like take away 50, but then I add 1, so take away 50, wait, why did I write a 4 then? It's gonna be 500, and if I took away 50, it would be 75, but I add 1 more, so 76. And that does look familiar. I think that, let me just double check this work. So 25 squared, did I get that right? 625, good. And square root of 576, I did get it right, it was 24, okay. That was my guess. B is equal to plus or minus 24, but can't have a negative, so 24. All right, so I have my 24, and I'm ready to sub into my equation. So I have my A was 3, oh, that's not A. A was 7, my A prime was 3, plus B was 24, and B prime, we don't know, let's just say that's B prime, and our C was 25, and our C prime was 0. Okay, so that whole thing is going to go to 0. So I have 21 plus 24 B prime is equal to 0. That means I have 24 B prime is equal to negative 21. Therefore, B prime is equal to negative 21 over 24. Both of those are divisible by 3. Divide the top by 3, I get negative 7. Divide the bottom by 3, I get 8. So I'm looking for negative 7/8, and there it is. And, okay, hold on. I don't know if it's A or D. Let me just double check, because there are 2 7/8. What is the rate of change of the distance between the bottom of the ladder and the wall? Well, if it's sliding down a vertical wall, okay, I see my mistake now. It was sliding down, so this should have been a negative 3, which means this would have been a negative 3, a negative 21, which means this was a positive 21, which means this was all a positive. It is a positive 7/8. I apologize. It was not A. I had a feeling that it wasn't A. The correct answer here is D. And that makes sense too, because if the ladder is sliding down the wall, it needs to be sliding away from B, which means it can't be a negative. It should be a positive if it's sliding away. So the correct answer here is D. All right, so that concludes the Self-Check 4.2. Remember, for tonight, our homework is going to be to do Self-Check 4.3, which means on Tuesday, the first thing that we're going to do in class is go over the solutions to Self-Check 4.3. All right, thank you for watching.